researcher and consultant from within the ESIPS team based in Addis Ababa, Ethiopia. Today, I'm going to index for rangeland early warning and monitoring using the Earth observation data, which is applied for Eastern Africa. It is a joint work that we work with for ICPAC and then within the GMS and Africa initiative for rangeland works. I'm going in detail a little bit more about it. My presentation will include the first part with the introduction, followed by the combined drought index input data and methods, the algorithms, the application part, and finally the result and how is it applied in the rangeland tool. So as an introduction, as you all know, the occurrence of drought is related to a complicated interaction such as precipitation and temperature, evapotranspiration, soil moisture and vegetation, which is to limit some. There are also a lot of impacts that are occurring that are happened for drought impacts. And then we have selected combined drought index because it has almost main variables integrated into one and estimate combined drought index based drought estimation. It's not actually a new index. It's one of the index that are listed in World Meteorology Organization handbook, and then currently it's being applied in Europe, mostly monitored by Joint Research Center, and then NDMC, which is the National Disaster Mitigation Center for Northern America, is also applied. And then it has also partially applied in some of the IGAD regions, which is in Kenya and Somalia by FAO Swallin, which is a particular project that's made for after a great drought that has happened in 2010 and 2011. We have done this work, as you just slightly mentioned in the beginning, developing of a dynamic system for monitoring, predicting rangeland quality quantity for drought status in the Eastern Africa. So CDI inputs are three: the precipitation component, the temperature component, and soil moisture component. In each component, there are two steps that are integrating. So when you say in precipitation component, it considers rainfall deficit and the persistence of dryness, which integrates into precipitation drought index. And then in the temperature component, it also considers two things, which is the temperature excess and then the persistence of high temperature. Finally, it integrates into temperature drought index. And then the soil moisture component also considers soil moisture deficit and persistence of dryness, since this is approximated by NDVI deficit, and finally it's followed by vegetation drought index. This is actually the algorithm that we have followed to develop this script. The drought index is the actual average for the interest period, which is the division of long-term mean for that interest period under square root of actual levels of continuous deficit for precipitation and temperature, and then actual excess for temperature, for NDVI. So we have also applied some modifications just to avoid division of zero and then unlimited numbers. So temperature is, as you can see, how we modified each variables. And then for NDVI, also precipitation. So finally, we have applied 50% weight for precipitation drought index and each 25% weight for temperature and vegetation. So as a data source in time step, we have selected our time step from 2001 until 2021. And then the drought is assessed, but it is a 3 monthly time step. And all the CDI in the tool is updated each time all the input variables is available. So for variable rainfall, we have used a TRIPS data set, which is from about 4 kilometer resolution, and temperature from GLDAS, which is 27 kilometer resolution, and for NDVI, spot rigidity spatial resolution of 1 kilometer. In general, this is a general schematic representation of the CDI. So as I explained to you, we have used monthly data for all the variables for precipitation, land surface temperature, and NDVI. And then each variable, like cherry precipitation, delta celeste, and spot VGT has been analyzed by pre-processing analysis, and then a modification has been done for all the 3 variables, and then we come up with an index of each variable, which is PDI, TDI, and VDI, and then we apply the weight, and finally we come up with a combined drought index. And then since we have done this for IGAT region, and then our interest was for rangeland, we found rangeland, and then aggregated by admin level 2. So just to see how we applied the CDI application, the CDI has 3 steps: watch, warning level, and also another warning level. A watch is the first application of which indicates a precipitation shortage, and then warning level is reached when the precipitation translates into excess moisture, and finally the last warning is when precipitation and soil moisture translate into an impact of vegetation. So if it is a value of less than 4, which says an extreme drought is happening, which majority loss of crops are happening, and then if it's greater than 1, which is normal, in that case there would be no drought. So now I'm going to show you some of the results that we have come up for the combined drought index results. The first result that we have seen, actually our main interest was all the way from 2018 on until 2021, but we want to check how the CDI has been resulted for back in 2010, since it was a great event of drought for Eastern Africa. So if you see from all the way from January until late of the year, until September, it doesn't indicate any drought on the IGAD region. But then when it comes to October, it translates into mild kinds of drought, and then November also resulted even for Somalia, it translates into moderate kinds of drought. All the way, it also translates into the eastern part of Ethiopia, Somalia, and also Kenya has been affected by the mild drought. You will see how it's also translates into 2011. It's also coming up in January until all the way to April, until after May, it becomes to normal kinds of situation. But then the city captured 2010, 2011 big drought index, the big drought events that has happened in the eastern parts of Africa. So we also analyzed 2018, the first, our recent year application, where for 2018, you may see that the year doesn't actually has much drought, but then particularly in February, it was resulted high kinds of severe kinds of drought. But then it was not elongated; it was just for that particular month. But since we have been communicating to some stakeholders that this was actually happening, but then the CDI has also been captured this event in that particular month. So the next one is all the way from 2018, 19 until 2021. We have produced maps, and this is just the result of 2020. This also has indicating some of the results for CDI, which is happening in the eastern parts of Africa, especially for November, December, which particularly the dry season has been captured for that particular year. So now, since our interest was on rangeland, we have masked out all the way, all the places that are not integrated as a rangeland. So we extract out the parts that are not rangeland. So this is a result of, again, 2020, which is only for rangeland areas. So just for you to see here is first one was it's a combined drought index. So just we have integrating all these 3 major variables for precipitation, temperature, and vegetation, just to see how the spatial distribution of each indexes that are on the left that are also an impact of for CDI. So if you the PDI has a lot of impact for CDI, and then you could actually see that in spatial distribution that are in each country. Also, TDI and VDI has actually an impact. This also can be seen in the droughts that have an impact for TDI. Finally, this is just to show you, we have produced also a lot, my colleagues have also produced a lot of biomass indexes, biomass applications, and then how is it going to be integrated for rangeland. So it's just some components of rangeland components that are integrated into one tool. This is now controlled by ICPAC, and then each time it's updating when the input variables are available. It has also some forecasts and monitoring, and then there will be an update of each time that the input variables are available. For CDI, right after the drift dataset, GLDAS dataset, and spot VGT is available, it will be updated each time. So when we were producing the CDI, we have been also updating the CDI maps after we download the input variables, which was mostly found from ICPAC GMS website. So now the final, my slide is how we are applying the CDI. As I told you, it's a powerful index to apply for drought by integrating key variables into one. Since it's integrating major drought variables, which is precipitation, temperature, and vegetation, and then real-time assessment of the Eastern Africa drought can be monitored by using the CDI. We have seen how the CDI has a powerful impact for application of drought for Eastern Africa. Yeah, that's my end of my presentation. I thank you very much. I hope I meet the time.
Yes, you did. Thank you so much for the wonderful presentation. I will now invite questions from the audience. Do we have any questions? Yes, Prof. there has a question.
Thanks, Tinebeb, for that beautiful presentation. Mine is a simple question. In light of this information that we have gathered about droughts, what suggestions do you have about mitigating against some of these hazards, if I may call them so? Thank you.
Very nice, very nice. Can you hear me?
Yes, we can hear you.
Hello?
Yes, we can hear you.
Actually, the first thing that for mitigation of drought, knowing where drought is always happening is a key issue. So for us, the first thing that we consider is how are we going to apply for where the drought is really happening. So real-time assessment of drought for mitigation is a key factor. So the main idea for us is how we see real-time the drought is where is it happening. So we are close to having a mitigation measures in place where, especially for rangelands, which is now biggest ecosystem component.
Okay, thank you. I have a question as well. I saw that the resolutions that you're using differed from between 4 kilometers to 27 kilometers for each of the drought indexes you used. For the indexes you used, that's precipitation, vegetation, and temperature. So how did you resolve that? And also how did you validate your data or your
Yeah. The reason that we have for temperature 27 kilometer of GLDAS dataset is because of the advantage of long-term average. We have another product which is about 3 kilometers also from ECPAC. We are looking how the dataset can be integrated into the CDI component, but then it doesn't have a long-term average. So it started for 2015 until now. So we see that TRIPS dataset actually is validated almost for Ethiopia. It's about 96% of all the station dataset. Like it's also having a station data. S after the TRIPS is for station. S stands for station. So for majority of the places that we don't have any complaint in terms of precipitation, which is a major component for CDI. But then for any DVI also, like we have spot widget, which is actually a legendary spot, legendary kind of any DVI input. The only concern that we had was for temperature, we couldn't use any other long-term temperature data. But then we are looking now how we are going to transform into the 6 kilometer, which is currently available for even for IGAD from ECPAC server.
Okay, thank you so much for your presentation.